Welcome to WAEC Physics 2026. You have the exam tomorrow. There are some for those who are writing CBT. So let's look at the questions. The question is both WAEC is both CBT and paper. For those who are writing CBT and paper, you might have the same question tomorrow. So let's see. The diagram below illustrates wave rectification by diode. I believe you know what a diode is. A diode is an electrical device that allows current to flow in one direction. So if you look at the input is given to us as a complete circle or wave. This is the input, it's given to us a complete circle or wave. Then this is the output. So our interest here is the output. Then it went through this process to give us this output. So they're now asking us now, what type of wave replication is this? So it moved from full to half. So I will call it question A, call it half wave rectification. Call it half wave rectification. Let's go to B. What types of electrical signal is the output voltage? What type of electrical signal is the output voltage? So the signal here will be can't see it clearly, but I can't see that person clearly. So let me go to the C part of it. I can't see that clearly. Then question C is identify the electrical symbol labeled X. So this is the X here. So our X, I will come back to that. Our S is the diode. Our X is the diode. So let's go to the next question. Let's go to the next question. Okay, it said the diagram below illustrates the energy level of a hydrogen atom. You say if the electrons in the first excited state emit photons, electron in the first excited state emit photons. So as it drops to the ground state, so this is the first excited state, while this is the ground state. The last one is the ground state, while the first one is the excited state. So from there now I can determine the energy. The energy now would be E1, E2, which is the excited state, minus E1, which is the ground state. So the energy in the excited state, let's check that. The value is minus 3.4, while the ground state is minus 13.6. I'm having minus 3.40 minus 13.60. So E will give me minus 3.40 plus 13.60. So E is now what? If I subtract from my A, I'm going to have 10.20 electron volts. But if you go back to the question, they gave us 1 electron volt as 1.6 times 10 minus 19. So the energy now will give us 10.20 times 1.6 times 10 minus 19 joules. So if I multiply this, what am I having? 10.2 times 1.6, that will give us 16.32 times 10 minus 19 joules. This is now the energy between the first excited state and the ground state. Let's go to the next question. Said the moment of inertia I is given by this expression. It gives us I as distance squared times weight times 9 times period squared over 16 pi squared times length. So derive the dimension of I, dimension of the moment of inertia now. So our I is given to us as distance squared times weight times 9, open bracket, period all squared, divide by 16 times pi squared times length. So for me to determine the dimension of moment of inertia, I need to know the dimension of each variable given to us. So for distance has the dimension as length, which is L. Weight has the same dimension as force, which is ml t minus 2. Then period has the same dimension as time, has the dimension as time, which is t. Then length dimension is L, is same thing as distance. So let's substitute them into the expression. So my I will be L squared, which is distance squared, times weight ml t minus 2 times 9 times the period, which is t squared, period squared, over 16 times pi squared times L. So I will apply the law of indices where necessary. Here is raised to power 1 for the L. So I will apply the law of indices to L and T. So the moment of inertia now become M. I'm having L 2 plus 1. I'm having T minus 2 plus 2 times 9 over 16 times pi squared times L. So if I simplify, that will give me M L raised to the power 3 T raised to the power 0 times 9 over 16 pi squared L. So I can apply the law of indices to the 2L. This one is raised to the power 1. So when the law says when you divide, you subtract. So I'm going to have I now to be M L raised to the power 3 minus 1 T raised to the power 0 9 over 16 pi squared, which is M L squared times 1 times 9 over 16 pi squared. So T raised to the power 0 is 1 according to the law of indices. So if you look at this, all this value here represents a constant. So the dimension is simply ml squared. That is the dimension of the moment of inertia. Let's check the next question. Question 6. It says a 10-meter long plane is inclined at 30 degrees to the horizontal. A ball is placed at the upper end, rolls down the length of the plane, of the inclined plane. So how long will it take the ball to cover the entire length? So let's see. So the plane is inclined, the length of the plane is 10 meters. So let's say this is the horizontal floor. This is not the plane now. Let's call the plane AB. And the whole length is 10. And the plane is inclined, according to the question, at 30 degrees. And this is a circular object here that is rolling down this way. Don't forget, the length of this plane is 10 meters. So we are asked to find the time it will take for the ball to roll down the plane. So if the ball continues rolling, it's going to form, let's say this ball has a mass, which is, here will now give us a mg. Then if I resolve, here will give me mg cos 30. Then the first here will give us a mg sine 30. The frictional force will go in this manner. Okay? So according to the Lambert principle in physics, it says summation fx equals to ma. Summation fx equals to ma. Okay, so what is the summation fx now? Some of the forces acting horizontally. The frictional force is not given to us, so it's regarded as 0. So some of the forces acting horizontally, or which is mg sine theta. So I'm going to have mg sine theta is equals to MA, such that A cannot cancel A. So I'm going to have A as G sine theta. So my A becomes, my G is 10 times sine 30, which is 10 times, sine 30 from my end here is 0.5. So my A will give me 5 meter per second square. So this is the rate at which the ball falls down. That's acceleration. We are asked to find the time it takes to reach the ground. So I have to find the time. So now we're plotting A, and the length of the rolling ball is 10. That is total distance is covered. So how do we get the time from there? So we're going to have x as u plus v over 2t. Okay, or x can also be ut plus half at squared. Since we have a, we cannot find the distance. Cannot find the time it takes to do so. So anyway, CS and the total length of the ball is 10. I'm going to have 10. The ball was at rest before it started moving, so initial velocity is 0 times t plus 1 over 2 times 5 times t squared. So 10 will give me 0 plus 5t squared over 2, which is written as 5t squared over 2. Everything here equals to 10. So my 5t squared will give me 2 times of 10, that is 20. So what will be our t squared? My t squared will be 20 divided by 5. The result is 4. T is now the square root of 4. The answer is 2 seconds. That is not the time it spent to roll down the plane. So let's see the next question, question 7. Let me check if some among the questions I was given. Question 7. Not there. So let's look at this particular question. The question number is not there. Say 3 forces act at a point as shown and illustrated below. Calculate the magnitude and direction of the equilibrium force. So let me redraw the diagram. Magnitude and direction of the equilibrium force. The equilibrium force is simply the resultant force. It's simply the resultant force. The equilibrium force is simply the resultant force. Okay, before then, we have a different question here, or this under the same question. Say, state one difference between resultant force and equilibrium force. So let's start with the resultant force. So A, multiple 1, resultant force. Resultant force is a single force. It's a single force whose value or magnitude is equal to the sum of all forces acting at a point. That is a resultant force. So y, let's differentiate it now. Y equilibrium force is a single force. It's a single force that keeps other forces in equilibrium. Or other forces in equilibrium. So that is the differentiation between equilibrium force and resultant force. So let's look at question A, 2. It said, the diagram below illustrates a uniform sphere of mass 4 kg in a position by two strings WX and YZ. WX is horizontal while YZ is inclined at 40 degrees to the horizontal. Calculate the tension in each string. So there will be tension here, we can call this one T1. There will be tension here, we can call it T2. So how do we find the tension on both? So let me redraw the diagram, and the sphere, they say it has a mass of 4 kg. So you know tension is measured in Newton. Tension is measured in Newton. That means I'll convert this kilogram to force by using weight as mg. So let me redraw the diagram. I'm going to have a situation like this. The angle here is 40 degrees, and here is Z. You have this sphere here. It has a mass of 4 kg. That the weight is now 40 Newton. Because we have weight is equals to mg. So here is point X, here is point Y, here is W. So let's call the tension here T2, let's call the tension here T1. So you can solve this question now using Lamy's theorem or resolution of forces or triangular of forces. So I prefer using Lamy's theorem. This place is 90 degrees. What is now the angle between these two forces now? Everything will give us 130 degrees. While the angle here is right angle, the angle here is simply 90 degrees. So what is now the angle between these two other forces? So you know angle at a point is 360. So I have 360 minus 130 minus 90. That will give us 140 degrees. So if I apply Lamy's theorem, I'm going to have W, this force here, 40 Newton, is proportional to the angle between these two, T1 and T2. So I'm going to have 40 over sine 140 is equals to, my T1 is proportional to 90. So I'm going to have T1 over sine 90 degrees is equals to T2 over sine 130 degrees. So I'm going to have, let's look for T1 first. We can equate both three of them. So I'm having 40 over sine 140 is equals to T1 over sine 90. So this one implies that my T1 will give me 40 sine 90 degrees divided by sine 140 degrees. So our T1 equals to what? So let's do that. Sine 90 is 1, so it will be like 40 divided sine 140. That will give us 62.23 Newton. That is now my T1. So let's get T2. For T2, I'm going to have 40 over sine 140 equals to T2 over sine 130 degrees. So if I make T2 the solid formula, I'm going to have T2 is equals to 40 sine 130 degrees over sine 140 degrees. So it implies that my T2 will be equal to, so let's multiply both of them, 40 sine 130 divided by sine 140. That will give us 47.7 Newton. That is not the value for T2. So let's go to the other question. Now, question Roman 3. It says three forces act at the point as shown in the illustration below. Calculate the magnitude and direction of the equilibrium force. The equilibrium force here is tantamount to our horizontal force. Equilibrium force here is tantamount to our horizontal force. So how do we find it? Now, to find it, you need to follow the direction of the force by using our sign convention. If the arrow is acting upward, it's positive. If the arrow is acting to the right hand side, it's positive. It's acting downward, is negative. Acting to the left hand side is negative. So if you look at this arrow, it's acting to the right. This one is acting to the right. So I have to resolve this. This one inclined at 35 degrees to the horizontal. We have to resolve that force. So how do we do that? So to do it, we need to redraw this diagram before we can resolve it. Let's redraw the diagram now. I'm going to have, this is the point. Angle here is 35 degrees. The force is acting this way. The force what? This is 5 Newton. Where you have 5 Newton. This one is also acting to the right, which is 4 Newton. So I will create my axis. This is the y-axis. This is the x-axis. Then the force here is 7 Newton. So you can see the angle 35 degrees is inclined to the x-axis, not to the y. So for that, I will resolve it. When I resolve this force, the vertical will give us 7 sine 35 degrees, while the horizontal will give us 7 cos 35 degrees. If you use SOHCAHTOA to do that. So what's my summation f of x now? What are some of all those acting horizontally? 4 is acting horizontal and it's a positive force, according to what you just did, follow sign convention. 5 is horizontal, it's positive also. 7 cos 35 is horizontal, that will give me 7 cos 35 degrees. So I'm having 9 plus, so let's get the value of 7 cos 35. That will give me 5.734. So if I add it to 9, I'm going to have 14.734 Newton. This is now the sum of all the horizontal forces. So let's also look for the vertical forces. We have only one force acting vertically and it's positive, which is 7 sine 35. So I have summation f of y, which just give me 7 sine 35 degrees. What is the answer to that? 7 sine 35. That will give us 4.015. 4.015. So with that, Newton, I will now draw my net force diagram. The net force diagram is that the y is positive and the s is also positive. So my net force diagram will be in this way. This is positive, while this is also positive. That's why I'm drawing it this way. Then the horizontal force or the equilibrium force will be here, which is R. So here now, which is the y, is 4.015 Newton, while the x, we calculated that earlier, 14.734. It's now 14.734 Newton. It's our right angle. Then the direction will be taken from here now. This is the direction now, which is theta. So we are looking for the magnitude now of the equilibrium for which is r, and the direction which is theta. So find arrow, we are simply going to use Pythagoras theorem. So my arrow square will be your summation f of x square plus summation f of y square. What is that giving to us? I'm having 4.015 plus 14.734 all squared. So I'm having, if I square the first value, that will give me 16.1205 plus 14.734 squared. That will give us 217.09. If I add up, what am I having? Plus 16.1205. That will give me 233.21. So the horizontal force is now what? Square root of 233.21. What am I having? Take the square root of that. That will give me 15.27 Newton. So let's get the direction. If I want to find direction, I will use SOHCAHTOA, which is opposite over adjacent. So direction, I'm having tan theta, which is opposite over adjacent, which is 14.734, which is value of the opposite. The adjacent is 4.01. So the opposite is 4.015. Opposite is 4.015. So I'm having 4.015 over 14.734. So tan theta will give me what? So 4.015 divided 14.734. I'm going to have 0.2725. So my theta now will be the tan inverse of 0.2725. Value of theta is now what? Tan inverse of my result. That will give me 15.2 degrees. This is now the direction. So we will write it as 15.2 degrees because it falls under the first contract. So this is solution to that question. Question number is not clear. So let's see the question we have next. Question B says state two differences between particle motion and wave motion. Two differences between particle motion and wave motion. So let's see. You can do that in tabular form. Question B. Particle motion. Here we have wave motion. So the first difference could be particle physically moves from one location to another. Particle could be anything. It can be your ball. Particle physically moves from one point to another. So what happens to wave motion in that regard? Transfer energy. You know that's the definition of wave. Transfer energy from one medium to another. From one medium to another. There's the second difference. Number two, so particles, if you kick your ball, it can be stopped when you apply force. Particle can be stopped by force. Particle can be stopped by force or energy. Can stop particle by force or energy. What about what happened to wave motion? It continue propagating. Continue to propagate. So that's different between particle motion and wave motion. So let's see the next question. Say the diagram below illustrates velocity time graph. Let me see. Diagram below illustrates velocity time graph. Okay? Look at them here. The diagram below illustrates velocity time graph. So what are the questions? So without, I don't know what the question might be, but I think this is uniform. This is uniform acceleration. This is constant acceleration, I mean. The first one is uniform velocity, or is uniform velocity or constant acceleration. That is the first diagram. Constant acceleration. Why the second one is uniform velocity. Uniform velocity. Uniform acceleration, I mean to say, uniform acceleration. So first is uniform velocity or constant velocity. When it's uniform, meaning the final is equals to the initial velocity, or constant acceleration. When acceleration is constant, the value is your A is 0. Okay? Then the second one is uniform acceleration. You move from one point to another. So let's see the next question. So I don't really know, can't see this question clearly, but it seems like, I don't know the question number, said mention two differences between universal gravitational constant and acceleration due to gravity. Two differences between universal gravitational constant and acceleration due to gravity. So you can put that also in a tabular form. Let's put that in a tabular form also. So here is a universal gravitational constant, which is G, while this is acceleration due to gravity. Acceleration due to gravity. What's acceleration due to gravity, which is small g. So first of all, we can differentiate them based on their SI units. So for what's the SI unit, universal gravitational constant? Let's assume I don't know it, I can derive it. We know that F is G M1 M2 over R squared. So my G will be what? F R squared over M1 M2, which is Newton meter square per kilogram square. So that is the unit. So I can use the unit to differentiate it. So here, number one, here will give me Newton per kilogram square meter square. Okay, while acceleration due to gravity is meter per second square. You can differentiate they're using their SI unit. Then what about their I can also use their quantity to differentiate it. I can use or use their values also. Gravitational constant have a value of 6.67 times 10 minus 11, while this one has 10 or 9.8. You can also use that to differentiate both of them. So if you have other differences, you can also indicate them. So my also number 3, and this is a scalar quantity. This is scalar. While this is the other one is a vector. This is scalar quantity. While this is vector. While this is vector. So we can use that to differentiate both of them. This vector quantity. So let's see next. It said two particles, A and B, of mass 20 grams and 50 grams, are separated respectively at 30 centimeters apart in the gravitational field. A third particle, C, is to be placed between A and B such that there will be no net force, no net gravitational force experienced. So calculate the distance of C from A. So let's illustrate with a diagram. We have two particles, A, another particle B. This particle has a mass of what? 20 grams and 50 grams. This is 20 grams, while this is 50 grams. So both of them, between centers, now center to center, they are separated by 30.0 cm. Then, so we have another force. We have another particle, C, that's placed between A and B, so that there is no net force. So we have another particle here, for instance, which is C. There is no net force. That means we have a repulsion and attraction between the forces. That's the only way there will be no net force. When repulsion plus attraction will give us 0. That's the way you can have no net force. So we are asked to find the distance between A and C. Let's call the distance between A and C as x. If the distance between A and C as x, what will now be the distance between C and B? If the whole length is 30, B and C will be 30 minus x centimeter. So I need to get the force between, so let's call the mass here as m grams. The mass of particle C, let's call it m grams. So I need to get the force here and the force here, so that both of them will give me, so that means the first force, if I collect like term, this one will come here, meaning FAC is equals to FCB. That's what it means. That's the only way we can have no net force. So what is FAC? According to Newton's law of universal gravitation, FAC will be GMA MC over r square AC. So G is constant, so we'll leave it there. G times 20 times MC, which is mass of C, I don't know. Distance is now x squared. So FAC will give me 20 GMC over x squared. Let's call it equation 1. Then FCB will be the same formula. We're going to have G MB MC over r square BC, which is G times 50 times MC over 30 minus x all squared. Let's call this one equation 2. So if I equate both of them, as we stated earlier, I'm going to have 20 GMC over x squared is equals to 50 GMC over 30 minus x all squared. So GMC will cancel GMC. 0 will cancel 0. So I'm having 2 over x squared is equals to 5 over 30 minus x all squared. So if I rearrange this, I'm going to have 30 minus x all squared over x squared is equals to 5 over 2. So I can group both of them as a common square. I'm having 30 minus x over x all squared equals to 5 over 2, which is something as 2.5. So let's make 30 minus x over s the subject formula. So what are we going to have? We're going to have 30 minus x over x now give us the square root. We're going to have the square root of square root of 5 over 2, which is, what is square root of 5 over 2? We are going to have 1.58. So from here I can cross multiply, so I'm having 30 minus x equals to 1.58x. So 30 will give me 1.58x. Collect items plus x, that will give us what? 2.58x. So my x is now what? 30 divided by 2.58. What are we having? 30 divided by 2.58, that will give us 11.6 centimeter. That's not the distance between A and C. Distance between A and C. Then question B says state 3 factors that determine the electrical conductivity of a material. So we know that from resistivity, R equals to resistivity length over area. So the factors now could be length, one, length of the wire, then 2, area of the wire, then 3, the resistance of the wire, So we also know that temperature also affects a wire. Let's say temperature also is also a factor. Temperature is also a factor. So let's see question B, Roman figure 2. Say a parallel plate capacitor of dimension 0.5 meter by 4 cm. So the unit is wrong from the beginning, 4 cm and 5 meters. So you have to convert the 4 cm to meter. That will give us 0.04 meters. But you cannot work with meter and cm at the same time. So we convert one to the other. So we have 0.04 meter. It's to be constructed to have a capacitance of this. If the dielectric constant is this, calculate the thickness of the wire. You calculate the thickness of the wire. We know from capacitor, which is question C now, we know that C equals to EA over D. EA over D. YE, which is the permittivity, is permittivity of free space, permittivity of air. So my C could be EOERA over D. So if you look very well, they gave us the dielectric constant, which is our K. So we're going to have, this will give us a, let me go back. Okay. Well, K is the product of these two, so I'm having KA over D. So with that now we can now find the thickness of the wire. The capacitor is given to us at 1.2 microfarad. You can see it clearly. So I'm having 1.2 times 10 minus 6 is equals to, let's check for the constant now, is 2. Constant is 2. It's equals to 2 times, we have the area now, which it says the area should be 0.5 times 0.04. I'm having 0.5 times 0.04 over D. So let's take it as such, over D. So from here, I can make the D the subject, formula. So my D will give us what? What did it give to us? D will give me, I make D the subject formula. I'm going to have, that is by cross multiplying, I'm going to have D to be 2 times 0.5 times 0.04 divide 1.2 times 10 minus 6. So let's multiply the numerator. I'm going to have 2 times 0.5 times 0.04. That will give me 0.04 divided by 1.2 times 10 minus 6. So if I divide 1.2 minus 6, that will give us error. Let me repress it. So my D will be 0.04 divide 1.2 exponent minus 6. That will give me 3.3 times 10 raised to power. That will give us 3.3 times 10 raised to power of, what am I saying there? Okay, let me check the question again. They give up permittivity of free space. Okay. So times free space, I need to include this 8.85 times 10 minus 12. 8.85 times 10 minus 12. Then that means I will multiply this by 8.85 times 10 minus 12. That permittivity of free space. So let me multiply. I have 2 times 0.5 times 0.04 times 8.85 exponent minus 12. That will give us 3.5 times 10 minus 13 divide 1.2 times 10 minus 6. So what are we having? That will give us 2.95 times 10 minus 7 meters. So this is now the value for the permittivity, the thickness. Value for the thickness. Then last question, they say define electromagnetic field. Electromagnetic field. Okay, let's do that. So electromagnetic field is simple. It's a region where electromagnetic force field can be experienced. It is a region, but let me just define it. It's a region where electromagnetic field of force, electromagnetic region of space can be experienced or felt. That is the definition of electromagnetic field. Okay, so let's go to the next question. I'm exhausted already. So here is question 10. We are asked to mention three differences between stationary wave and progressive wave. So let's see how stationary is also called a standing wave, while progressive wave is also a traveling wave. So let's put that in tabular form. A, figure 1, is stationary, while this is progressive wave. So although it's not a must, you must put them in tabular form. So, but it's easier to do it that way. So stationary wave, it's a wave formed by the superposition of two identicals waves traveling in opposite direction. So that is stationary. Why a progressive wave? A wave traveled through a medium, a wave traveling through a medium. A wave traveling through a medium and continuously transferring energy. So that is one of the differences. So you can also use other differences because of time factor. I'm going to stop it here so you can find the other differences to it. Roman figure 2 say a progressive wave has an amplitude of 6 meters and a velocity of 110. If the frequency of the wave is 160 Hz, write down the progressive wave equation. So we know that, let's say what is given to us, but give us velocity, giving V as 110 meters per second. We are giving amplitude as 6 meters. And we are giving frequency as 160 Hz. We know that A is A sine, Y is A sine angular t minus 2 pi x over lambda. So Y angular itself is 2 pi f. Angular velocity is 2 pi f. So with that, I can now form my progressive wave equation. But if you look very well, the lambda is not given to us, but we have a relationship that says V is equals to f lambda. So my lambda will simply be what? V over f, which is 110 divided by 160. That will give us 11 over 16 meters. That is now my wavelength. So if I substitute now, I'm going to have my y to be 6 sine, put brackets, 2 pi f. My f is 160 times 2, that is 320. I'm going to have 320 pi t minus 2 pi x over lambda, and lambda is 11 over 16. So if I invert, I'm going to have 16 times 2 pi x divided by 11. So my y is now 6 sine 320 pi t minus 32 pi x over 11. So this is now the progressive wave equation. Then the B part, it says define harmonics and overtone. Harmonics and overtone. So harmonics and overtone deals with sound. They are sound waves. So let's take the first one. Number 1, harmonics. Harmonics. Harmonic is any frequency. Any frequency that is an integer multiple. Integer multiple of the lowest frequency, The lowest frequency is also called the fundamental frequency. Lowest frequency or fundamental frequency. that is harmonics. So it's simply like F equals to NFO. The frequency harmonics now is the integer times the fundamental frequency, where fundamental frequency is your FO. Y overtunes the numerator 2, we have overtunes. Overtunes is any resonance. It's any resonance frequency system, frequency of a system that is higher than the fundamental, frequency, So that is the definition of harmonics and overtunes. Now, if you look at question B, say write down the equation showing the relationship between the refractive index n, minimal deviation dn, and the refractive angle A of a triangular glass prism. So the B Roman figure 1, we have n equals to sine dm, which is the minimal deviation plus A, divided by 2 over sine A over 2. This is the relationship. So let's go to Roman figure 2. It says the refractive angle of a glass prism is 50 degrees. If the refractive index is 1.41, calculate the minimum deviation. So n is given to us as 1.41 and A is 50 degrees. So let's see that. So my n equals to 1.41, then my A is 50 degrees. My dm, I don't know. So let's check that out. So I'm having into the same formula now. Let's put it in the formula. Yes, let's put it in this mathematical formula now. I'm going to have mathematical 2 now. 1.41 is equals to sine dm plus 50 over 2 over sine 50 over 2. So, which is sine dm plus 50 over 2 over sine 25. That is 50 divided by 2. So if I cross multiply, I'm going to have sine dm plus 50 over 2 is equals to 1.41 sine 25. So let's press that. 1.41 sine 1.41 sine 25. That will give us 0.5959. So my dn plus 50 divided by 2 will give us the sine inverse of 0.5959. So what is the sine inverse of that? Second function sine, we have 36.6 degrees. So I can cross multiply. So I'm having my dm plus 50 is equals to 2 times 36.6. dm plus 50, that will give us 36.6 times 2, that will give us 73.2. So my dm is simply 73.2 minus 50. So dm will give us 23.2 degrees. That's not the minimal deviation according to the question. So that is all for question 10. Let's check for the other questions. I don't know if there are more. Okay, this is question 9. It says state the 3 differences between sensible heat and latent heat. Sensible heat is also known as specific heat capacity. While we know all the amount of heat under specific capacity, latent heat is heat hidden or absorbed without the changing in temperature. So you can differentiate them. Let's see. Number 9 now. We have sensible heat. Then you have latent heat. So first one, you can differentiate by formula. For sensible, my Q is MC change in temperature, while for latent, Q equals to ML. So you can use your mathematical formula to differentiate them. This one, number 2, it's affected by temperature. Affected by temperature. Okay. There's no change in temperature. No change in temperature. Okay. So, number 3, it depends. The two one depends on mass, specific heat capacity, and change in temperature. This one depends on mass and the specific latent heat. So that's the 3 differences between both of them. So let's see. It says we should state natural sources of heat. So what are the natural sources of heat? That is Roman figure 2. Roman figure 2. You have the sun. The sun is a natural source of heat. Then we also have geothermal energy, the one Abia people are using, geothermal energy. Abia are using geothermal energy. That's why they have heat, light always. So this is the heat you obtain from the earth crust. Geothermal you obtain from the earth crust, so it's natural. You don't need anybody intervention. Then you also have friction. When you rub our palm against each other, it will generate heat. So let's leave that one there. Then, so we should state 2 advantages of mercury over alcohol as a intermetric substance. So we know you can differentiate them based on their temperatures and their state. One wet glass, one do not wet glass. So you can figure that out. Because of time, you can differentiate them. One is more sensitive to temperature than the other, and the other one wet glass and one do not wet glass. That should be mercury against alcohol. Then that's the difference between both of them. Let's see the question B. Say resistant thermometer read 10 ohms when placed at ice and 110 when placed at steam. So B, say 10 ohms when placed at ice and 110. So 10 ohms. This is now 100 degrees Celsius. This is okay. 110 at steam, 110 ohms at ice. The ice has a temperature of 0. So they are not asking us. Calculate the temperature of the liquid at which the thermometer reads 75 ohms. So at 75 ohms, that will be intermediate temperature now. I don't know that temperature. Let's call it T. So if you are to employ interpolation method here, I'm going to have the highest minus the lowest and the intermediate minus the lowest. So I'm going to have T minus 0 over 100 minus 0 is equals to That is 75 minus 10 over 110 minus 10. So if I simplify this, I'm having T over 100 is equals to 65 over 100. 100 we just cancel 100. The temperature there now is 65 degrees Celsius. Temperature there is 65 degrees Celsius. Then question B, Roman figure 2. It said an effective and electric heater of 60 watts be able to heat 150 grams of water. So the power given to us now, the power they gave to us is 60 watts, and the mass of water it heats is 150 grams. So, figure 2, our power P is 60 watts. Then the mass of water MW is 150 grams, which I will convert to kilogram, which is 150 divided by 1000. So mass of water will give us what? Let me divide from my end. 150 divided by 1000. That will give me 0.15 kilogram. Okay? It said changing temperature from 60 degrees to 110. So I'm having theta 1 because it's 60 degrees Celsius, and my theta 2 is 107, I believe. Should be 107. Let me check again to be sure. 107 degrees Celsius. So we are asked to do what? So calculate the time in minutes for the heating process. So we should calculate the time in minutes. My T I don't know. And they give us specific capacity of water, CW, as 4200 joules per kilogram per Kelvin. So we know from Joule's law of heating and the specific capacity, we have that PT is equals to MC change in temperature, which is MC theta 2 minus theta 1. So I'm having 60T equals to 0.15 times 4200 times 107 minus 60. So I'm having 60T is equals to 0.15 times 4200 times 107 minus 60. That will give us 47. So I multiply the 3. 47 times 4200 times 0.15. That will give us 2961. So my T is now what? 2961 divided by 60. What are we having? That will give us 49.35 seconds. So we are asked to convert the time to minutes. We know that 60 minutes, we know that 1 minute is equals to 60 seconds. So if I want to convert this time to minutes now, I'm going to have my T to be 49.35 times 1 over 60. Now I'm dividing it by come again. Well, that's 60 seconds is equals to 1 minute. So 1 minute. The time now will be is 49.35 seconds. So if I convert it to minutes, I'm going to have T equals to 49.35 divided by 60. What are we having? Divided by 60. That will give us 0.8225 minutes. So this is now the answer in minutes. So it says state two factors that affect both heat capacity and cooling uh, cooling process. So one of them must be temperature. Temperature affects heat capacity and cooling process. The second should be nature of the substance. Nature of the substance. Nature of the substance. So these are the two factors. So I think this is all the questions. And this is our channel, STEM Up Africa. Follow us by subscribing, liking, and commenting on the channel. You can reach us on YouTube, Facebook, Instagram, TikTok, Twitter, and the rest. So I will post mass soon enough. So stay tuned to the channel. Thank you for watching.